What we're looking at here is exercise 1, array program 1, which is just sort of a sample of basic array processing. We're creating an array by providing it a list of items. We're actually, through all the exercises, we're going to look at a couple of different ways to get data into our array. For right now, though, we're just looking at something very basic. We're starting out at the very beginning. So we start out by setting up an array of scores. These are test scores, essentially. Notice the code used to create the array, the data type, variable name, and a set of square brackets, which again let Java know that we're talking about an array or list of data. We're setting it equal to, and then the list of items we want put in that array. Inside curly brackets. Each item in the list is delimited by a comma. So at position 0, at index 0 will be 25. At index 1 will be 36. At index 2 will be 100. At index 3 will be 75. And at index 4 will be 15. There will be a total of 5 items in this list. As you were building this program and going through the instructions and the various steps, we started out by just adding everything together, and then as we rolled through to the very end, excuse me, we decided to also look to find the largest and smallest values. We set up an integer called sum to store the running total, if you will, of the items in the list, because we are going to add them all together. We create an integer called largest. And we started out with the value of the first item in the list. Same thing with smallest. We also started out with the first item in the list. Now you might be thinking about okay, why don't we want to start them at 0? If 0 is a valid value in the list, that would be fine. But because 0 is not a valid value in the list, it is possible that 0, for example, would be the smallest number. But 0 doesn't even exist. So we want to always make sure that when we're looking for largest or for smallest, we started out with, when we're looking for, what item is the largest or what item is the smallest, we always start out with a value in the list. And we keep only looking at values in the list, and we don't bring in any outside values at all, even in initialization. Simply because we want to make sure we're only using legitimate values. So we want to make sure that we're only looking at values that are one of 5 possibilities: 25, 36, 100, 75, and 15. So no matter what, whenever you get in a situation like this, it's always a good idea to set those variables, to initialize those variables to the first item in the array is usually a good idea. Again, we're going to use a for loop to process this array. Why write the code 5 times? If you recall from the last discussion we had in class, the last class period where we met, we talked about loops. And the whole idea of loops was so that we didn't have to write code over and over and over and over again. We could put it in a loop and it would repeat as many times as necessary based on that test. So that's what we did here. We're starting at 0 because we're setting I to 0. We're starting at 0 and we're going right up to, but not including, the length of the list or the length of the array. And for every item, we're going to take that value that we're looking at of the item in the array, we're going to add it to sum, and then we're going to check to see if it is either the largest value or the smallest value. And that's what we're going to do. When we're all finished with that, when we've looked at all 5 items, we're going to come down here and display a dialog box that looks at the sum, the average, and what's average, right? The total of all of the items added together divided by the number of items. That tells you what the average score would be, especially when we're dealing with scores. We are then going to look at the largest score and the smallest score. Now, what I'm going to do is I'm going to go ahead and set some what we call breakpoints so we can go through and take a look at exactly how this execution is going to work. Just so we can see. I'm not going to start out, well, you know what? Yeah, let's set some breakpoints up here too, just so we can get an idea of how, if you decide to use the debugging features in NetBeans, what that's going to look like and how you can see the array and what values sit where in the array. And let's go ahead and take a look. Now remember, I am looking at the finished program here. All right, I am looking at the finished program. So we've got everything set up. We've gone ahead and set up our array, and we've loaded it with values. That was the very first line. And if you look down here towards the bottom of the screen, what you see is what you see, and you see it up here too. You see string and a square bracket. You see int and a square bracket down here on the scores line. What those square brackets tell us is those are arrays. Those are lists of data. Over here we see a memory address 303, which it's not truly a memory address. It's not hexadecimal, but that's okay. And we see a length of 5. That tells us how many items are in the array. You'll see that there's a little caret over here I can pop out. And all of a sudden underneath scores, we start seeing 0, 1, 2, 3, and 4, along with some values. These are the indexes of the array. And what you see in here is the type of data stored at that location, and then the value of that data. And you can match these up 25 to 25, 36 to 36, 100 to 100, 75 to 75, and 15 to 15. So you can see that the order that the items are loaded when we create an array by providing it a list, the order that the items are loaded into the array dictates their index. So the first item goes into index 0, the second item goes into index 1, so on and so forth. We're going to go ahead and set up sum. We're going to go ahead and set up largest. And we're going to assign to largest the value of the first item in the array. And so if I scroll down here, actually largest, these are in alphabetical order, so largest is up here. We'll see that largest is set to 25 because the value stored at scores index 0 is 25. And when we're finished with the creation of the smallest variable, we'll see the same thing, right? We're assigning it whatever value is sitting at scores index 0. Scores index 0 is 25. So if I scroll down here and look at smallest, smallest also has the value of 25. Now we're going to get into the loop. All right. 0, we first set I to 0. We're then going to say I less than 5. Is 0 less than 5? I mean, let's look at this. Scores.length comes back with 5. And I is 0. So is 0 less than 5? That's a true statement. 0 is less than 5. So we're going to execute the body of the loop. That means we are going to get the first item in scores, which is 25. We're going to add it to sum, which is currently 0. And sum is now going to be 25. And we can see that down here. We're then going to access the value stored at scores sub 0 or scores index 0. How do I know that index is 0? We're using whatever the value of the variable I is. Now remember something that I told you earlier. Because this requires an integer, we're not stuck with a literal integer. Anything that would evaluate out to be an integer, so an integer variable, some math that would result in an integer is valid here. We can put that in. What's going to happen is it's going to process that statement, and it's going to come up with a number, and it's going to stick that number in scores. In this case, it's going to look at I, and it's going to look at what the value of I is. And if we go here and look at our variables, I is currently 0. So it's just like, say, scores, square bracket 0. So we're going to look at the first item of our array, which is 25. And we're going to compare it against largest. And if 25 is bigger than largest, we're going to assign the value of the value of that item in the array to the variable largest. In this case, they're the same, so they're not bigger. And we're going to do the same thing with scores, except we're looking to see if the current item is less than whatever we currently have stored as smallest. And in this case, they're not, so we're going to keep going. So we go in again, and now I is 1. So we're doing all of this work on the second item of the array. First, we take 36 and we add it to 25, and we get 61. We're then going to check and see, is 35 is the value stored at scores sub 1, or scores index 1, is 36 greater than 35? It is. So largest no longer contains the largest value. So we're going to change that. We're going to take the current value of x, or of scores index 1, and we're going to stick it in largest. And is 36 less than 25? And that answer is no. We're going to do this again. I is now 2. So we're now looking at scores index 2. That's 100. So we're going to take 61 and add 100 to it, and we're going to get 161. We're then going to ask the question, is 100 bigger than 36? Last I checked, 100 was bigger than 36. So we're going to go ahead and replace the value in largest. Is 100 less than 25? Nope. So we're going to keep right on going. Now I is equal to 3. So we're looking at the fourth item in the list, or index 3. That's going to be 75. We're going to add 75 to 161, and we're going to get 236. Is 75 greater than 100? The answer is no. And is 75 less than 25? And again, that answer is no. We're going to move on to the next item, which I will be 4. So we're looking at index 4, which is 15. So we're going to add 15 to 236, and we're going to get 251. We're going to ask the question, is the value stored at index 4, which is 15, greater than 100? And the answer is no. And then we're going to ask the question, is the value stored at index 4 less than 25? 15 is less than 25, so we're going to rewrite the value in the variable smallest. We're going to turn I, we're going to add 1 to I at 4, so I is going to become 5. We're going to test, is 5 less than 5? The answer to that question is no, they're the same as. So we're going to leave the loop, and we are going to display a message dialog box that contains all of the information that we just figured out. 251, if you divide 251 by 5, you get 50, roughly. The largest score was 100. The largest item in the list was 100. Now, this could have just been a list of integers, but in the problem, I laid out that this was a list of scores. That's how we know it's a score. The smallest score here is 15. And again, we know that because as we move through each item in the list, we checked. We looked to see. We asked. That's really all this program does. You can see the power of the loop, right? We didn't have to write all this code right in here 5 times. We wrote all of this code once. And yet we were still able to check every value in the array. Make those comparisons. Do the addition. Evaluate those items. This is where the power of the array lies. That and its flexibility. We can make that array as big as we need it. Now, don't get me wrong. We can't resize it. It's not the solution to all problems. But it is a solution to a lot of problems and a lot of things, a lot of data structures that we have now. All of these more fancy data structures, like when we get into database, in some languages, database design, they have these things called database data rows or data tables, are all based on the concept of an array or a multi-dimensional array, which we'll talk about in 130. This is to me, it is a very interesting concept. It's a very interesting concept. All of the rest of the exercises 2 and exercise 3, which would be the ones that we'll go over in videos, just show you how to get data into the array from different ways. The basic processing of the array doesn't change. So in the other 2 programs, we're going to limit our review to just the changes and how we get items in. Exercises 1, 2, and 3 will be necessary to do your homework. Exercises 4 and 5, while interesting, are for you to do on your own. I will not be going over them with you. The step-by-steps, I think, are good enough. You should be able to get through those on your own. They're very interesting. One even includes working with polygons, working with the polygon shape generator. So I think that you'll find that very interesting. Again, this is the ArrayProgram 1. So you finished watching this, you can move on and work with ArrayProgram 2. And if you have any questions, you can email me or bring them into class. Thank you.